This is 5.7b of geometry. So we looked at the hinge theorem in the last video. Now we're going to look at the converse of the hinge theorem. So the other one said if the angles are bigger, then the side must be bigger, right? Now we're looking at if the side is bigger, then we can say that the angles are bigger. So same thing, we need the two sides, right, congruent, and we're looking at the angle in between and the side opposite. But now we're going to start by looking at the sides and then look at the angles. So when we're using it, we can figure out a range using algebraic expressions. Let's look at this got it problem down here. So I've got this side congruent to this side, and this one congruent to this one, so I'm ready for my theorem. So this side is 9, and this one is 7. So this is the bigger side, which means this down here is the bigger angle. Remember, the square means 90, so that angle, 90, this one down here, needs to be bigger than this angle over here, which is 3x plus 18. And then I'm going to solve it. So I'm going to subtract 18 from both sides. I get 72 is greater than 3x. Divide by 3, and I get that x is less than 24. But here's the thing, that's not the end of it, because can I have a negative angle? Can I have negative degrees? No, if I don't have a limit for the bottom, I could say, oh, well, negative 4,622 is less than 24, right? So I need to put a limit on the bottom. Whatever this comes out to be, it needs to be bigger than 0, right? If I have a 0 degree in a triangle, it's not actually a triangle. The two sides are just going to be on top of each other. So I also need to say that 3x plus 18 needs to be bigger than 0. So I'll subtract 18. 3x is greater than negative 18. Let me move it over here because I'm running out of room. I'll divide both sides by 3, and I get that x is greater than negative 6. Which first seems wrong. Like, hey, you just said we can't have negative degrees. That's not okay. But we don't. Right now, this is just the value of my variable. Okay? This is just what I'm going to plug in. If I plug in, let's say, negative 5, because negative 5 is bigger than negative 6. If I plug in negative 5 for x, I get negative 15 plus 18, which is 3. So the measure of the angle would be 3 degrees. And that's okay, right? So it's okay if my variable is negative. It still gives me a positive answer as long as it's bigger than negative 6, what I said right here. Okay, and finally a theorem. We're just going to do the got it problem, a proof. We're just going to do the got it problem down here. So the first thing I need to do is write my given. Okay. It's a long one. Okay, so the angle MON is 80, so I'll mark that in here. If that's 80, I know that this is a straight line, right? So these two angles here need to add up to 180. So that means that LOM is 100. So the measure of LOM is equal to 100. And that's definition of linear pair. I'll let you get away with calling it supplementary, but linear pair is the real one. The other part I haven't used in my given is that O is the midpoint of LN. What does it mean to be a midpoint? It means that it splits it in half, right? The midpoint is right in the middle. So, if O is the midpoint, I can say LO is congruent to ON. And that's just the definition of midpoint. And I'll mark that on my triangles. So I've used everything in my given. Just looking at my picture, I can say that MO is congruent to MO bireflexive. And now I'm all set up for my theorem. Am I set up for the hinge theorem, or am I set up for the converse of the hinge theorem? Remember, the hinge theorem starts with the angles, and then it can say that the side is bigger, whereas the converse starts with the sides and says that the angles are bigger. Well, I've already got my angles, so I'm using 513, the hinge theorem, not the converse. So, since 100 is bigger than 80, I can say that LM is greater than MN by 513, which is the hinge theorem. And there we go. There's your homework.